So the next speaker is by Dr. Jesus Fernandez about the CORDEX stuff. So please start.
Thank you. I will be talking about CORDEX and the plans that we have for CMIP7. But I will start with a brief introduction to the CORDEX initiative, since maybe not every one of you is aware of it. CORDEX is a scientific pillar in the WCRP core project RIFS for Regional Information for Society, so it's not under ESMO as CMIP. And the aim is to advance and coordinate the science and application of downscaling through global partnerships, with the goals of using downscaling to understand relevant regional to local climate phenomena, their variability and change, evaluate and improve regional climate downscaling models and techniques, and actually produce coordinated sets of regional downscale projections, and also to foster the communication and knowledge exchange with users of these projections. CORDEX is one of the main features of CORDEX is the organization into regional research communities, which focus on 14 different domains worldwide that you can see there. This main activity is called CORDEX domain, and the idea is that the different communities work more or less independently. We have common protocols, but work more or less independently, covering, using different downscaling techniques, these domains that you see on the screen. This is the most known, maybe, activity in CORDEX, but we have some other activities. For instance, we have flagship pilot studies, which address emerging scientific challenges and typically focus on smaller areas and on finer scale processes. And we have a stronger observational and user interaction in these flagship pilot studies. We have, at the moment, 10 different flagship pilot studies running, for instance, focusing on island climate. There are 3 of them. We have several of them. Well, there is one focused on the urban environment, spread all across the world, and several others. And they use different approaches, such as convection permitting simulations, decoupling to the ocean, machine learning techniques. But as I said, these work more or less independently from each other. So in 2025, we launched what we call the task forces. These were very short-term activities to try to coordinate these approaches. There were task forces on regional ocean modeling, on convection permitting modeling, on machine learning, and we have other 2, one on the CORDEX core experiment, which I will be mentioning in 1 minute. And there was also one task force on the preparation for CORDEX CMIP7. These task forces did some planning and the strategy that we could follow in the future in CORDEX, providing some recommendations, but did not actually implement these recommendations. This is done now in what we call task teams. The only one of these which is actually running is the task team on protocol and infrastructure for CORDEX CMIP7, the TTPI, which I will present in this presentation. And there are other task teams associated to the other task forces. And there is also a working group on regional ocean climate projections, which is a joint working group, along with the CLIBAR core project, with the ocean modeling development panel in this core project of the WCRP. As I said, these task teams and working group are still to be formed, and there will soon be an open call to get members. And there will be a strong emphasis to engage members from diverse regions, expertise, and also linking with other WCRP initiatives and beyond. So if you are interested in any of these topics, please consider applying for these task teams. About the simulation status, at the moment, we have a monitoring system. You can see here how many simulations for each domain there are available, which are planned, which are running and completed. And one thing you can see is that here on the lower right, you can see domain by domain how many simulations are available. These are future projections. There are dozens of them in several of the domains, but you can also see that there are some domains which did not have that many simulations covered. For this purpose, we have what we call the CORDEX core experiment. It stands for Coordinated Output for Regional Evaluation, and this is a cross-domain experiment. So here we really coordinate across the different domains with the idea of having a homogeneous and balanced ensemble that can provide global projections with these regional climate simulations. And we go for 12-kilometer resolution. We use the same 3 driving GCMs that you can see there, and we use the same 4 RCMs across the different domains. We are focusing on scenario SSP3 7.0 for this experiment. And if we see the status of this, it's also not quite advanced, but the plans are that it will be more homogeneously distributed across the different domains, and it will be even more in the near future. We should have 12 simulations for the future for each of these domains, and all nested into the same GCM and RCM across the different domains. These are some recommendations that came out of the task forces that I just mentioned. One of them is from CORDEX Core, that should be seen as the CORDEX contribution to each cycle of new scenario simulations in coordination with the CMIP, high-res MIP, or ICMIP simulations that also come out for each IPCC cycle. In addition to the CORDEX domain simulations, we should evolve towards regional Earth system model frameworks in the different domains. This is already the case, for instance, in the Mediterranean domain, but we should move towards these more coupled components in the rest of the domains. Also, we need to improve the consistency of the climate forcings with the driving GCNs because, for instance, the land cover was static in the simulations in CORDEX CMIP6, and we need to update this. We should approach the kilometer scale resolution at continental scale. We are already there for subcontinental efforts that need more coordination. And since we are overlapping the kilometer scale with the global kilometer scale community, we should link and engage in common studies with this community. An important topic is the severe inequities that come with this increasing computational demand. There were several domains with no simulations. This is, of course, because in these regions the groups cannot afford to perform the simulations, but the situation is even worse because not even they cannot perform the simulations, but at the moment they cannot even analyze the results because of the huge amounts of data that we are managing and the resources that they have there. We should adopt even more fair practices for CORDEX, meaning that the data, metadata, and protocols that we produce should be findable, accessible, interoperable, and reusable as much as possible. And we are also exploring the potential of the coordination of machine learning-based downscaling and RCM emulators towards a global framework with multiple methods and multiple complexity. In this sense, we are running a machine learning benchmark from CORDEX, which you can join. If the presentation is shared afterwards following this link, you can have more detail on this benchmark. These simulators will allow CORDEX to mitigate the current problem that it has, which is essentially not being able to produce large ensembles or long runs with these regional climate models. And we will try to fill or expand this phase space of this plot that you have seen already several times. So the machine learning would allow to cover this high spatial resolution and at the same time having large ensembles. Going to CMIP7, or in fact going to CORDEX CMIP6, because we are still in CORDEX CMIP6 is still ongoing. We are still doing simulations for CORDEX CMIP6, and there are some key steps still pending because these data are not published yet. So this means that we will still need several months for the public to be able to access the simulations, and then the CORDEX CMIP7 will come very close in time to the CORDEX CMIP6 era. So this will affect the protocols that we have to develop the CORDEX CMIP7, and we will have two different streams. One is focused on CMIP7 AFT, and here we will minimally adapt the protocols to provide some CMIP7-based CORDEX information for AR7. And if emulators are ready, this will be used to expand this stream. And the CORDEX CMIP7 itself will be a standard stream over a longer time frame, including new approaches, model and climate forcing developments, and representing a next generation downscaling. This will require a lot of steps. We are currently working on the experiment design, the driving GCM selection, and the monitoring of the simulations, the data request, and the archiving specifications, and we will have still several other steps that will need to be tackled. And this is being done but by what we call the Task Team on Protocol and Infrastructure, the TTPI, which started activity in January 2026. Several technical aspects. The data request was filed under the Impacts and Adaptation theme. We have two opportunities related to CORDEX. One is called dynamical downscaling with 7 variable groups, and we have ESD and emulators with 3 variable groups. Please contribute to these opportunities as much as you can. At least what they are called the core variable groups are the minimum that we need to run our models, both the statistical downscaling, the dynamical ones, or the emulators. There are new variables to support the ocean component and the atmospheric chemistry, and take into account that this is a quite demanding data request because we need 6-hourly 3D data on model levels. So maybe only a few members can provide the data for this opportunity. The one point that I wanted to make here is if we can know in advance which groups, models, experiments, and members will support the CORDEX opportunities that I just showed. GCM evaluation and selection, I won't be talking anything about this because there is a side session tomorrow. Okay, please come. It's in the same room at more or less at the same time. And we will be discussing different selection practices in downscaling and other areas. So we'll skip this as well. The scenario prioritization. During the Open CORDEX Chat in November 2025, we decided to prioritize the high overshoot scenario, first with concentration-driven simulations and then emission-driven, and as a third priority, the high scenario. This is to complement the existing CORDEX CMIP6 simulations because this overshoot is a novelty in AR7, and this will complement the simulations from CORDEX CMIP6 instead of the users going directly to the latest generation of scenarios. So this was our idea, then to focus on the high and the low to negative, as they are called now, but and this is quite consistent with what we had in CORDEX CMIP6, which is this SSP3 7.0 and 1 to 6. But the low to negative will not be available, so we are considering now to use the HL, the high to low scenario for this CORDEX CMIP7 AFT. We are developing openly all of our protocols and infrastructure under GitHub, and you can follow the experiment design and all the discussions that we are having, for instance, on the selection of scenarios and so on there. My time is over, so I will just leave the summary there, and if you have any question, I will be pleased to answer. Thank you.
Thank you. So any questions from the audience or online?
Yes, hi, thanks for the presentation. I'm a bit confused about the scenario choices because I have not heard that the low scenario won't be available, or as far as also my information is still that we as CMIP modeling centers should prioritize the low and the high scenario to deliver.
The first priority, as far as I know from CMIP7 AFT, is the high and the very low. And second priority is the medium and the high to low, which is this pink one here, which is an overshoot, but a very late overshoot that only goes down by the end of the century to right below the 3 degrees. And we were considering to use before this other one down here, which is the overshoot reaching nearly 2 degrees and then going back to 1.5. And this is not prioritized at all at the moment, I would say, but maybe somebody can correct me if I'm wrong about this priority.
Maybe it's a confusion about who prioritizes what, but yeah, thanks.
I mean, this is our priority is this, and the priority from CMIP7 AFT in principle, as far as I know, is this one. I don't know if...
Any comments? Oh,
I thought maybe I'd respond with my understanding of the prioritization. So all of the scenarios would be under the fast tracking principle, right? HMVL almost available. The part that takes a bit longer is running the ozone. And so my understanding is that the second wave of priority, and then there will be a third wave of priority in a sense. And I think this is in part then determined by the forcings task team, how this priority is setting. I don't know if that's something that could potentially be revised or so. I don't know about this, but at least in terms of emissions and land use, those should be available before the timeline that you say. I'd assume the sequencing might happen on the ozone running side. And so I'm not sure about the need, but you seem to have had some discussions already. But maybe that's Eleanor knows more. There we go.
So it's a kind of practical issue because for 2 of the forcing data sets, they can only do 2 scenarios at once. So for ozone and land use, they can only do 2 at once. So it's kind of like which ones were going to be first, and then the next 2, and then the next 2. So it's just a kind of like capacity issue for those forcing data sets.
Okay.
So thank you very much.
you.
So it's time for the next talk. Thank you.